What if I told you an Oklahoma mechanic figured out how to build a 550 horsepower engine using nothing but junkyard parts that cost him $150? Not some exotic race motor, not some heavily modified custom build, just factory AMC parts that nobody else thought to combine. This is the story of how one engine builder accidentally discovered a combination that AMC's own engineers never knew existed, and how his moshed homemade stroker motor became the terror of Midwest drag strips in the 1970s. Net in and picture this. It's 1973 in Oklahoma City. Gas prices are through the roof thanks to the oil crisis. Muscle cars are dying. Insurance companies have killed performance. The EPA is strangling engines with emissions equipment. And in a small garage on the outskirts of town, a guy named Kaufman is about to stumble onto something that'll make the big-money engine builders look like absolute fools. He's measuring crankshafts from junked AMC engines when he notices something odd, something that shouldn't work, something that AMC's own engineers apparently never tried. The stroke dimensions between the 390 and 401 engines are compatible. Dead simple observation, revolutionary implications. And this wasn't supposed to happen. Major manufacturers don't accidentally leave performance on the table. They don't overlook simple part swaps that create 50 more cubic inches. They certainly don't miss combinations that turn their mid-level engine into a fire-breathing monster. But that's exactly what American Motors Corporation did. And Kaufman Racing was about to expose it to the world. To understand why this discovery was so significant, we need to travel back to the late 1960s. AMC was the little guy, the perpetual underdog. While General Motors, Ford, and Chrysler were slugging it out with massive engineering budgets and dedicated racing programs, AMC was just trying to survive. They'd introduced their new generation of V8 engines in 1966. Clean sheet design, modern thin-wall casting, plenty of potential. The 390 cubic inch version appeared in 1968, marketed as their big block fighter. 315 horsepower from the factory. Decent for the era, but nothing special. Then, in 1971, they released the 401. Same basic block architecture, different crankshaft, different stroke, different displacement, and an etc. Here's where things get interesting from an engineering perspective. The AMC 390 used a 3.574-inch stroke crankshaft. The 401 used a 3.680-inch stroke, just over a tenth of an inch difference. Doesn't sound like much, right? But in the world of internal combustion engines, stroke length is everything. It determines how far the piston travels up and down in the cylinder. Longer stroke means more displacement. More displacement means more air and fuel. More air and fuel means more power. The factory never intended these parts to be mixed. Different part numbers, different applications, different service procedures. No factory manual ever mentioned swapping cranks between engines. No AMC engineer ever published a tech article about it. No official documentation existed anywhere suggesting this was possible. But Kaufman wasn't reading manuals. He was measuring actual parts. And when he mic'd out those crankshaft journals, he discovered something extraordinary. The main bearing journals were identical. The rod bearing journals were the same size. The thrust bearing surface matched perfectly. The rear seal diameter was exact. Everything that mattered for fitment was completely interchangeable. You could literally pull a 401 crank from a wrecked Matador in a junkyard, drop it into a 390 block from a Javelin, and create something AMC never built. A 406 cubic inch stroker motor. And the math was beautiful in its simplicity. Take the 390's bore of 4.165 inches, multiply by the 401 stroke of 3.680 inches. Factor in 8 cylinders, you get 406 cubic inches, but displacement was just the beginning. The longer stroke changed everything about how this engine behaved. It increased piston speed. It improved cylinder filling. It enhanced the leverage on the crankshaft. It created more torque at lower RPM. The combustion chamber volume stayed the same, but now you were cramming more mixture into it. Compression ratio went up. Volumetric efficiency improved. The cam timing that was mild in a 390 suddenly became aggressive in the stroker. Here's what made Kaufman's discovery so brilliant. Custom stroker crankshafts in 1973 cost $1,200 minimum. That's about $8,000 today. And that was just for the crank. You still needed special pistons, custom rods, machine work, balancing. The total bill for a traditional stroker build easily exceeded $3,000. 500 horsepower from a small block required deep pockets. But Kaufman's approach hit the junkyards. Find a wrecked 1971 or newer AMC with a 401. Pull the crank for $50. Grab the rods while you're at it. Another $30. Find a good 390 block from any AMC vehicle built between 1968 and 1970. Maybe $70 if it's really clean. You're into this thing for $150 and you haven't even started the machine work yet. It's the first engine Kaufman built using this combination was a revelation. Using nothing but factory AMC parts, mild porting on the heads, a decent cam, and a proper carburetor, he was seeing 550 horsepower on the engine dyno. Not estimated, not calculated, measured, verified, repeatable. 550 horsepower from an engine built with junkyard parts. The torque numbers were even more impressive. Over 500 pound-feet by 3,500 RPM. Peak torque at 4,200 RPM. This thing would absolutely destroy tires from a standing start. On N-word spread quickly through the Oklahoma racing community. Kaufman started showing up at drag strips with nondescript AMC-powered cars that nobody took seriously until the tree went green. Then these junker javelins and beat-up rebels would launch like rockets, pulling the front wheels off the ground, charging down the quarter-mile in times that made the big block Chevys look slow. The Mopar guys couldn't believe it. The Ford racers were in denial. How was some backyard mechanic with AMC junk beating purpose-built race cars? And the technical secret went deeper than just displacement. The 401 crankshaft's longer throw increased what engineers call the rod-to-stroke ratio. In the 390, this ratio was 1.638 to 1. With the 401 crank, it dropped to 1.589 to 1. Lower rod ratio means the piston dwells longer at top dead center. The combustion event has more time to build pressure before the piston starts its power stroke. The rod angle becomes more favorable for transferring force to the crankshaft. It's a subtle change, but in racing, subtle changes win races. Nenchen Kaufman also discovered these engines responded incredibly well to traditional hot rodding tricks. The factory AMC heads had decent ports but conservative valve sizes. Larger valves from a 401 head would drop right into 390 heads with minor machine work. The intake ports could be opened up significantly without hitting water. The exhaust ports were already pretty good but responded well to cleanup work. A good valve job with 3 angle seats would pick up 20 horsepower easily. Port matching the intake manifold gained another 15. These were all simple modifications any competent machine shop could handle. Nanset, the camshaft selection was critical. The longer stroke meant the engine wanted a different cam profile than a stock 390. Kaufman found that cams designed for big block Chevys worked perfectly in the stroker AMC. The added displacement and improved rod ratio let the engine handle more duration and overlap without losing bottom-end power. A cam that would make a 390 doggy below 3,000 RPM would pull like a freight train in the 406 stroker. From idle to 6,500 RPM ignition timing was another area where the stroker differed from stock. The increased cylinder pressure from the higher compression ratio meant the engine needed less total advance. Where a stock 390 wanted 36 degrees total timing, the stroker was happiest at 32 degrees. Too much advance, and it would detonate on pump gas. Not enough, and it was lazy. Finding that sweet spot was crucial for both power and reliability. And the oiling system needed attention too. The increased loads from the longer stroke and higher power output stressed the stock oil pump. Kaufman discovered that the high-volume oil pump from a 401 Police Interceptor package would bolt right in and provide the extra flow needed. The stock oil pan was marginal for drag racing. Under hard acceleration, oil would slosh to the back of the pan and starve the pickup. A simple homemade baffle welded into the stock pan solved that problem for about $5 worth of steel. And NON fuel delivery was straightforward but critical. These engines loved carburation. A properly tuned 750 CFM Holley double pumper was perfect for street and strip use. Bigger wasn't better. The 406 cubic inches didn't need an 850 or 950 CFM carb like the big blocks. The excellent cylinder filling from the long stroke meant the engine was incredibly efficient. It could make big power with moderate carburetor sizes. This also helped with street drivability. You could cruise around town without loading up the plugs, then unleash hell at the drag strip. Non-exhaust was where many builders went wrong. They'd assume this engine needed huge headers, like a big block. Wrong. The AMC ports were smaller than Chevy or Chrysler big blocks. Moderate primary tubes, 1 3/4 inches with a good collector design, worked better than massive 2-inch tubes. The stroker made its power through torque and efficiency, not high RPM breathing. It was perfectly happy spinning to 6,500 RPM, but didn't need to. Peak power came in at a very streetable 5,800 RPM, and the transmission choice was interesting. While everyone else was running expensive race-prepped Turbo 400s or built 727 torque flights, Kaufman discovered the AMC-built Borg-Warner automatic could handle the power with minor modifications. Stronger clutches, a shift kit, and a good converter were all it needed. Another example of using what AMC provided rather than spending big money on aftermarket parts. The factory AMC rear axles were plenty strong too. The Model 20 rear end that everyone dismissed as weak would live behind the stroker if you used good axles and didn't run slicks bigger than 10 inches wide. And by 1974, Kaufman Racing had become legendary in Midwest drag racing circles. They were running consistent 11-second quarter miles with street-driven cars, not trailer queens, not purpose-built race cars. Street-licensed, pump-gas-burning AMC sedans that could drive to the track, run number that would embarrass big-block muscle cars, and drive home. The consistency was remarkable. While the high-strung big blocks would hurt parts and require constant maintenance, the AMC strokers just kept running. Change the oil, adjust the valves occasionally, maybe a new set of plugs every few months. That was it. The psychological effect on competitors was devastating. Imagine spending $10,000 building a race engine, thousands more on the car, countless hours tuning and testing, only to get your doors blown off by some guy with $150 in junkyard parts. The Chevy guys would tear their engines apart looking for problems. The Mopar racers would accuse Kaufman of cheating. Nobody wanted to believe that AMC, the company that built Gremlins and Pacers, had accidentally created one of the best performance engine combinations of the era. AMC themselves seemed oblivious to what was happening. While Kaufman and a growing number of copycats were terrorizing drag strips, the factory was busy neutering their engines for emissions compliance. The 401 was discontinued after 1974. The 390 soldiered on through 1978, but in increasingly strangled form. By the time AMC figured out what racers were doing with their engines, it was too late. The company was struggling financially. Performance was dead. They'd moved on to fuel economy and compact cars. But the knowledge didn't die. Kaufman's discovery spread through the AMC performance community like wildfire. Enthusiasts started documenting the combination. Which years had the best blocks? Which cranks to look for? What other factory parts could be mixed and matched? The 390-401 stroker became the worst-kept secret in AMC racing. Everyone knew about it, but nobody outside the AMC world believed it. How could Junkyard parts make that kind of power? The answer lay in the fundamental engineering of the AMC V8. Unlike the other manufacturers who had different engine families for different displacements, AMC used one basic architecture for everything from 290 to 401 cubic inches. This modularity meant parts interchange was extensive. It also meant the engineers had designed plenty of strength into the bottom end. These blocks could handle far more power than the factory ever intended. The main webbing was thick, the cylinder walls were substantial, the head bolt pattern was robust. It was overbuilt for emissions-era power levels, which made it perfect for performance applications. Niner and Kaufman's engines started showing up in unexpected places. Road racers discovered the stroker's broad torque curve made it perfect for tracks with varying speeds. The instant throttle response from the long stroke meant you could power out of corners harder than with a peaky big block. Circle track racers loved the reliability. You could run a full season without rebuilding if you maintained it properly. Even boat racers started using the combination. The marine environment was tough on engines, but the simple, overbuilt AMC design thrived. And the cost advantage couldn't be overstated. In an era when racing was becoming increasingly expensive, Kaufman had found a way to go fast for cheap. A complete stroker build, including machine work, could be done for under $500 if you were smart about parts sourcing. That same $500 might buy you a camshaft and valve springs for a competitive Chrysler Hemi. The democratization of speed was revolutionary. Suddenly, working-class racers could compete with wealthy teams. All you needed was knowledge and a few trips to the junkyard. The technical lessons from Kaufman's discovery went beyond just making power. It showed that factory engineers don't always explore every possibility. Corporate structure, departmental boundaries, and production constraints mean that obvious combinations get overlooked. The person who designed the 390 crankshaft probably never talked to the person who designed the 401. They were working on different projects at different times with different goals. Nobody ever asked, what if we put this crank in that block? Until Kaufman did. And it also demonstrated the value of hands-on experimentation over theoretical analysis. No amount of computer modeling or paper calculations would have suggested trying this combination. It took someone with micrometers and an open mind to discover it. Kaufman wasn't constrained by what the manual said. He measured, he tested, he tried things. When something worked, he refined it. When it didn't, he moved on. Pure empirical hot rodding at its finest. The stroker combination exposed the conservative nature of factory power ratings too. AMC claimed the 401 made 330 horsepower in its hottest configuration, yet here was essentially the same engine making 550 horsepower with basic modifications. Were the factory ratings wrong? Not exactly. They were measured differently, with full accessories, exhaust restrictions, and conservative tuning. But it showed how much potential was left on the table. Every factory engine was a compromise between power, emissions, durability, and cost. Remove some of those constraints, and power exploded, and then by 1976, the word was fully out. Speed shops started stocking stroker kits, specifically for the AMC 390-401 combination. Aftermarket companies began making pistons designed for the longer stroke. Cam grinders developed profiles optimized for the stroker's characteristics. What started as one man's junkyard discovery became a cottage industry. But Kaufman had the last laugh. While everyone else was buying expensive aftermarket parts, he kept winning with junkyard takeoffs. His secret wasn't the parts. It was understanding how to make them work together. The longevity of these engines was remarkable. While big block Chevys were known for spectacular but brief power, and Chrysler Hemis required constant attention, the AMC strokers just kept running. There are documented cases of Kaufman-built engines lasting entire racing seasons without being opened up. Street-driven examples would go 100,000 miles, making 500-plus horsepower. The overbuilt bottom-end, moderate RPM operation, and excellent oiling system created a package that was almost impossibly durable for its power level. The influence extended beyond just AMC applications. Other racers started looking at their own manufacturers' parts bins differently. If AMC had missed this combination, what were Pontiac, Oldsmobile, or Buick engineers missing? The concept of junkyard engineering took off. Why spend thousands on aftermarket parts when factory pieces from different applications might work better? This philosophy would eventually lead to discoveries like the Buick 350 heads on Oldsmobile blocks, the Ford 400 crank in 351 blocks, and dozens of other combinations that the factories never intended. And Kaufman himself became something of a folk hero in the AMC community. He didn't patent his discovery, didn't try to monetize it beyond building engines for customers. He freely shared his knowledge with anyone who asked. His attitude was that if AMC wasn't going to explore their engine's potential, someone had to. He saw himself as completing the engineering work that the factory should have done. In interviews years later, he expressed frustration that AMC never acknowledged or capitalized on his discovery. They could have offered a factory stroker kit, could have used it in Trans Am racing, could have marketed it as a performance option. Instead, they ignored it, while their company slowly died. The environmental angle is interesting too. In an era of massive displacement increases to make power, Kaufman's stroker was relatively efficient. 406 cubic inches isn't small, but it's modest compared to the 454, 460, and 500 cubic inch engines others were building. The excellent combustion characteristics from the long stroke meant it could run on lower octane fuel than comparable high-compression engines. It didn't require radical cams that wouldn't idle or work with power brakes. You could build one that passed emissions testing while still making genuine power. Try that with a tunnel ram big block. The stroker's success also highlighted the importance of local knowledge and innovation. This wasn't something developed in Detroit's engineering centers or Southern California's speed shops. It came from Oklahoma, far from the traditional centers of automotive performance. It showed that innovation could happen anywhere if people were willing to experiment and share knowledge. The Midwest drag racing scene that adopted the stroker early became a hotbed of AMC performance development, contributing numerous other discoveries about these engines. In the 1970s drew to a close, the AMC stroker had proven its point thoroughly. It dominated bracket racing, where consistency mattered more than outright speed. It won street races where reliability and drivability were crucial. It showed up in everything from pro stock to pure stock, always punching above its weight class. The $150 Junkyard Special had become a legitimate performance platform, respected even by those who'd initially dismissed it. And the technical legacy lived on long after AMC ceased to exist. When Chrysler bought AMC in 1987, they acquired not just the Jeep brand, but also decades of accumulated knowledge about these engines. Chrysler engineers were amazed to discover what the racing community had been doing with AMC V8s. Some of that knowledge influenced later Chrysler performance development. The modularity and parts interchange philosophy that made the stroker possible became a design goal for modern engines. And today, the 390-401 stroker combination is still built by AMC enthusiasts. The junkyard parts are harder to find and more expensive when you do find them, but the basic formula Kaufman discovered still works. Modern technology has refined it further. Better pistons, improved oils, Modern cam profiles and electronic fuel injection can push these engines even further. But the fundamental genius of dropping a 401 crank into a 390 block remains unchanged. It's still one of the most cost-effective ways to make serious naturally aspirated power. The broader lesson from Kaufman's discovery transcends automotive applications. It's about questioning assumptions, about measuring rather than assuming, about trying combinations that shouldn't work. How many other fields have similar undiscovered possibilities? What other simple swaps or combinations are waiting to be found? The Oklahoma mechanic who outsmarted a major corporation's engineering department proved that innovation doesn't require massive budgets or advanced degrees. Sometimes it just takes curiosity, careful measurement, and the courage to try something different. The story also speaks to the ingenuity of American hot rodders. Faced with corporate indifference and increasing regulations, they found ways to make power anyway. They turned junkyards into speed shops. They made obsolete engines competitive with cutting-edge technology. They proved that knowledge and creativity could overcome financial limitations. In many ways, Kaufman's Stroker was the perfect embodiment of hot rodding's democratic spirit. Speed for the people, by the people, from parts the corporations threw away. And looking back, it's tempting to wonder what might have been if AMC had embraced Kaufman's discovery. Could a factory-backed 406 Stroker have saved the company? Could it have given them a competitive advantage in Trans Am or NASCAR? We'll never know. But we do know that one mechanic with a micrometer and an open mind discovered something that an entire corporation missed. He found performance where others saw junk. He built power from parts others discarded. And in doing so, he created a legacy that outlived the company itself. Nentent. What's the most impressive fishy junkyard engineering discovery you've ever encountered? Have you ever found an unexpected parts combination that transformed a project? Drop a comment below and share your own story of outsmarting the factory engineers. And if you enjoyed this deep dive into one of performance history's most unlikely success stories, make sure to subscribe. We're just getting started exploring the forgotten innovations and accidental discoveries that changed automotive history. Until next time, keep questioning what the manual tells you. Sometimes the best performance comes from breaking the rules.